So prime numbers are numbers that have two factors, right? They can't have one, they can't have three, they have to have two. So is one prime or composite? Trick question. Neither. Yeah, it's neither. It doesn't fit prime because it has one factor. It doesn't fit composite because it has one factor. The definition for prime is two factors. The definition for composite is at least three, right? And one has itself. That's it. Yeah.
So what is
one is can't fall into either of the definitions. So it can fall into like odd numbers. It can fall into other ones like natural numbers, whole numbers, blah, blah, blah. But as for prime and composite, it doesn't fall into either. Okay, so our first prime number is 2, and it's our only, I need a pen. It's our only what? Even. So we have 2, 3, 5, 7, 11, 13, 17, 19. Multiples. Start at that number, go up by that number, correct? So if we said multiples of 3, for example, then it would be 3, 6, 9, 12, 15. You should be having definitions on your paper, the ones that I'm speaking. Factors are what? What times what equals what? Yeah.
Two numbers that you multiply into numbers.
Two numbers that multiply to give you that number. Yeah. So if I did factors of 12, let's say, as my example, I would have 1, 12, 2, 6, 3, 4. Could I be a rebel and like write 1, 12, 2, 6, 3, 4? Yeah. It actually makes me a little queasy, but you could totally do that. Because the order doesn't matter. It's just that since I was little, we've always had to write them in order. So I always work my way from outside in. So the second one makes me a little feverish, but it's not wrong. It's totally fine. Okay. Subset. Definition of a subset. Okay.
The set of numbers from a number?
Yeah. So for example, if I had A as a subset of B, all the elements in A have to be contained in B. B can have more, that's totally fine, but it has to have at least what A has. So an example would be if A was 1, 2, 3, B would have to be what if A was a subset of B? 1, 2, 3, and that would be enough, correct? They could actually be the same. I could also add smiley face, and this would still be true. Right? Okay, we have the universal set contains the natural numbers less than or equal to 15. That's the key thing. That's the universal set. That's the set that I can only pull numbers from. So it's like if I took all these numbers and I threw them in a hat, the natural numbers 1 to 15, that would be my universal set. So I would have 1, 2, because natural numbers start at 1, the ones you naturally start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do I include 15? Why? That is equal to. So the universal set is like if I take all those numbers 1 to 15 and I throw them in a hat. And now I say make set A, B, and C out of these numbers. And they're in this hat, right? Can I use 20? Can I use 576? No, I can only use what's in this hat that's holding all my universal numbers. Okay, that's what the universal set is. So I take all those numbers, I throw them in here, and then I say, now I'm going to make some subsets of it. All of the sets are subsets of the universal set, correct? Because I'm only being able to choose from the universal set. So set A contains even numbers. So I can't use like 700. I love it, it's even, cool, it's not part of my universal set. It's not in a hat of numbers. Okay? So I would have 2, 4, 6, 8, 10, 12, 14, and I have to stop there because I have to stop there. So I only have the numbers 1 to 15 in my hat. Okay? Is A a subset of the universal set? Yes, any set that you pull from the universal set is a subset of it, right? Because that's the only place I could take it from. Now B are the prime numbers. I start at 2, and I do 2, 3, 5, 7, 11, 13. Done. And then C are the factors of 20. I set you up for this one. Factors of 20 are 1 and 20, 2 and 10, 3 and 5. Correct? But I still can only pull the numbers that are in my little universal set hat. Correct? So what numbers are of those are in my universal set hat? 1, 2, 4, 5, and 10. I can't include 20 because it has to be a subset of the universal set. And if I put 20 in, it would no longer be a subset. Yeah.
Why can you include 1?
Because it's still a factor of it. Right? Just because 20 is pulled out doesn't mean 1 isn't a factor. I would state all my factors. I would say they're 1 and 20, 2 and 10, 4 and 5. And then I would say, okay, now which one of those can I take out of the hat? I can take 1 out of the hat, 2 out of the hat, 4 out of the hat, 5 out of the hat, 10 out of the hat, 20. Nope, just can't take 20. All right. So that little e means an element of. We've used it in domain and range the whole time. Is 20 an element of C? Is that true or false? It's false, which a lot of people put false, which is correct, but they didn't justify. So why is it false? I would say 20 is not an element of C, as 20 is not in what? 20 is not an element in the universal set. Two, that little sideways C means a subset of, correct? Is A a subset of the universal set? Yeah, is A contained in the universal set, all the elements? Yes, so it's true. And how you would justify that is to say every element in A, in set A, is an element in the universal set. It's important that if you don't have it justified correctly, you're writing justifications down on your page. You keep the daily quizzes there for you. They should be filed in a text, in a binder. They should not be filed in a textbook or in your backpack. Like your binder has rings. I feel some people use the binder as a file folder. Like it has rings, so if you just open those little circle things, the papers have like 3 little holes, like the circle things, there's 3 of them. And then you put the little circle things into paper, into the little circle things, into the binder, and then you close it. And then you can go like this. It's a crazy thing. I know. I'm only explaining it because I feel like some grade 12 still don't know it. It's often grade 12 boys. They don't know their binders open. It's the craziest thing. They just like, especially the ones with like zippers, they just think they just throw them in there and then they zip it shut and then install it. But they actually, the binder isn't a folder. Like, it's straight. Like, look at it. And you do this. Just teaching everyone. It opens. Another fun fact, you can close it nicely like this, or you can close it like this. But what I would suggest, I know this is new for some of you, is I would always open it like this and not like this. Why? It breaks the rings. It's a crazy thing. My child is still adapting to it. I have to buy her a new binder because she has made the rings off kilter. And then some people say to me, Mrs. Lepp, the rings are off kilter. I have to use my file folder binder because the rings no longer work. And are you a file folder binder dude?
It's so much more.
But watch this. No, it's not. It is not. It is efficient to throw it in like this, right now.
Yeah.
But then when I have to go find my notes, it is not more efficient.
It was like 49.
It's efficient for 2 seconds.
It's 5.
It's efficient for the time being, but it isn't efficient tomorrow when you look up daily quiz books. Yeah, it's crazy. I'm just going to leave that with you as an option. All right. B is a subset of C. Is that true or false? False. What element in B is not in C? B has 3 and 7 and 11 and 13, correct? B has the elements. I don't know what I'm writing. I think I'm putting the elements together. That's like, yeah, we should still be scared again. It's happening. The elements. What were they again? 3, 7, 11, and 13. That are not elements The number of elements in set C is what? How many elements are in set C? 5. The other way they can write it is n of C. Supposed to be a bracket. N of C, and the answer to that would be 5, right? The little n means the number of elements in, same as the words. Okay, determine the number of elements in B complement. The complement of B, I got you. That's okay. Okay, the complement of B. So B has 2, 3, 5, 7, 11, and 13. The complement of B would have 1. Oh, that was stupid that I just did. 1, and then 4, and then 6, and then 8, 9, 10, and then 12, 14, 15. Correct? So that would be the elements, but it wants the number of elements. So the answer is not that. The answer is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer is actually 9. Is the complement of A a subset of B? The complement of A would be 1. Immediately we're done. Right? The complement of A has 1 in it, B doesn't. It's completely done. So no. The complement of A has the element B. The element B. Nope. Has the element 1, which immediately makes it not a subset of B. Okay, you have the daily quiz 2. Bold quiz. Yeah. Put it nicely in your binder in those things that I talked about that were called rings. Okay, we're going to start it. If we haven't done this yet in our lives, we're going to open those bad boys up. We're going to put the papers in it. We're going to open those bad boys up. You have like the best ring binder ever. You could fit like 8,000 pages in that thing. And then we're going to put the papers in it. Then we're going to close them. And then we're going to open up our notes. We're going to go through Daily Quiz 2 tomorrow at the very beginning of class. So you should be here, a 2-circle Venn diagram. We have talked about these sets in different ways. Make sure everything is down, you're not being distracted. Okay, we've learned about sets, and we've talked about sets, and we've talked about intersection and subset and union, and we've looked at the sets as they've been literally written down. But what we can do is we can also compare them on Venn diagrams. You've seen Venn diagrams before. It's 2 circles overlapping or 2 circles not overlapping. 2 circles not overlapping would be disjoint circles, right? They would have nothing in common, so then you wouldn't draw the overlap of them. Or if you did draw the overlap would be empty. It wouldn't have anything in it because you wouldn't have anyone overlapping. So for example, if I said the people in this class who are in 30-2 and 10 common, I really hope that those are completely disjoint sets because you need 10 common to be able to do this class. None of you are in 10 common currently, right? If I was talking about who's in those classes currently together, you would have all of you here, and then this would be empty, and there would be no overlap because you can't have people. However, if I talked about people in 30-2 math and 30-1 to whatever social, just social, say math and social, there's going to be some of you who will be taking both, usually. Sometimes it could be the case that they're disjointed and everyone took social last semester, but that's a rare occurrence that would happen. Okay? So, here it says, consider the following 2 sets, subsets of the universal set of natural numbers less than 20. So I'm going to write those out first. So the universal set is that, that's terrible. I don't know what that was. Didn't want to write it when I drew it. Oh, it's not liking me, but that's okay. The universal set are like the numbers or the people or whatever it is that are sitting in this hat that I'm allowed to draw from to make other subsets of, correct? So the universal set for this question are the natural numbers less than 20. Natural numbers start at what when you're naturally counting as a child? 1, and then we go to, it says less than 20. So what are we going to? 19. And we're going to write them all out. And the people who choose to be lazy and not write these out will often do way worse on a test because they'll miss a couple numbers. So just using a little less pencil because you're lazy can result in much lower marks. So always do and write what I'm doing. If I'm writing it every single semester, you can write it too. Okay, we're writing it together. So pick up your pencils and write. So universal set of numbers less than 20. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The little squiggly brackets mean the set of, right? That means the set of numbers, and these are the numbers that are in that set. 1 to 19. So we consider the following two sets, subsets of the universal set of natural numbers less than 20. So A are the natural numbers less than 20 that are divisible by 3. Divisible by 3 means I put 3 in and I get out what kind of answer? Yeah, a whole number. I get out a natural number. I get out a not decimal, technically, right? So if it's divisible, you get out actual natural numbers, whole numbers, even numbers, not decimals. So of these numbers, the ones that are divisible by 3, okay, right down here. Divisible by 3 would be 3, then what? 6, 9, what else? 12, 15, 18, curly, squiggly bracket. Can we do round brackets or square brackets because we don't like curly brackets? No, curly brackets mean the set of. Round and square mean like inclusive or equal to or not equal to. They mean totally different things. So if you do this, that's not going to work. If you do this, and it's kind of rounded, it doesn't matter. Like just keep going until you get 3 of them. I don't really care. That will count as a squiggly bracket, right? You don't have to overthink it. It doesn't have to be perfection. Just that gets me a squiggly bracket. This way gets me another squiggly bracket, right? Okay. We're not marking you on the beautifulness of your squiggly bracket. It's actually not even called a squiggly bracket. I'm using some completely lower technology. All right. Divisible by 5. So B equals, the ones that are divisible by 5, what are they going to be? 5. 5, then what? 10, then what? 15. Okay. The next one says divisible by 3 and 5. Just 15. Right? And means it has to be in both. Or means either or I list it. Or often more, right? Or the word is in more. So you often get more with or, because if it's in one or it's in the other, I list it. Okay? And it has to be in both. The only one that's in both. So if I went, this would be written as A intersection B, right? That means and. And remember we talked about the intersection. If you can write the word and out of it, it means and. Yes? This one, can I write the word and out of it? No, that's stupid. So this one would mean or. Literally how I narrow it down. Not mathematically, just silliness. Okay? So I need A and B, which would be 15. And then A or B is going to be a lot more, correct? If it's in A or it's in B, even if it's in both, I list it. So I'm going to list all the ones in A, I'll list ones all in B. So I'm going to get 3. I like listing them in order. If they're not in order, are you wrong? No. On a diploma, they'll be listed in order. But if you don't list them in order on a written response, you're not wrong. I will, though, always. So 3, then 5, then 6, then 9, then 10, 12, 15 is listed in both, but I just list it once anyways, and 18. So if it's in A or it's in B, we list it. Just like if you were in math or you were in social, I'd write your name down. If I ask for people in math and social, you'd have to be in both, then I could write your name down. So think about it in subjects. If you get confused with and or, think, oh, she can only write my name down in math and social. So if I was in math and social, I get my name written down. If I was in math or I was in social, I get my name written down. So then that's the same thing. Like, or means more. So we're going to flip over. I don't know why this is. Okay. So I want to show the ones that are in A and B. How many numbers are in A and B? 1, and it is the number what? 15. So I'm going to write it in this eyeball. So the eyeball shape, if you're like, that's not an eyeball. Yeah, it is. Just wait. My artistic abilities shine. You're all going to be jealous. You're all going to be haters. It's totally fine. Look how that just appeared to be an eyeball. My daughter would like cry if I showed her my eyeball. She's artistic and I am as well on a different level. This actually looks like a real eye. And, okay, so we're going to put the number 15 in the eyeball. And this is what you do. We are actually representing the element 15, the number 15, not 15 objects there, correct? It's the number 15. So when you're representing that, you just put a little dot behind it so that you show that that's actually the number 15, not 15 objects. Okay? Now we have to put the numbers that are in A, we have to label this. So this is going to be A, this is going to be B, okay? We need to still list the ones that are in A, but just not in B. So that would be 3, 6, 9, 12, 15, and then 18, I believe. I don't remember. Yeah. So if you look at the A circle, the whole A circle, it has all of the numbers that we had in A, correct? We just only in the overlap part put the ones we had in B as well. You see what I'm saying? Because 15 was the only one that was in B as well. So it got lifted in the overlap. Now we have to do the numbers that are in B as well, right? So what was in B? 5, 10, and 15. We agree? What's already in B? It just happens to also be in A. 15. So what do we have to have in B only? Which is 5 and 10. Most people are pretty good at that. What most people forget is to list the numbers that, do you see how the Venn diagram has a box around it? It has a box around it for a reason. Because that box represents the universal set. So every number in the universal set should be located in that box somewhere. It might not make it into the circles, but it has to be in that box, right? So the universal set was the numbers, natural numbers from 1 to 19, right? So if it's listed in the circle, we don't list it outside. So 1 isn't, so we're going to put it out here. 1. Now we could draw them randomly all over the place if we want to, but I'm kind of lazy, so I'm going to just draw them along the bottom. So 1, 2, 3 is already in there. 4, 5 is already in there. 6 is already in there. 7, 8, 9 is already in A. 10's in B. 11, 12's in A. 13, 14, 15's in both. 16, 17, 18's already in A, and then 19. Is my Venn diagram going to change depending on what question I ask you? Is the Venn diagram itself going to change, or how many I picked from it going to change? How many I picked from it's going to change, but that Venn diagram is going to stay the same the whole way along, right? 15 is shared by both. 3, 6, 9, 12 is in the A. 5 and 10 is in the B, right? So the Venn diagram itself isn't going to change. The answers are going to change. So I want the number of elements. Remember, that's what that little n means. The number of elements in A and B. So how many are in A and B? There's 1. That's it. 1. Done. Because it's going to be this area here. Because and is the eyeball. Do you agree? Now, I'm not going to rewrite the numbers every single time, but I am taking a specific shape. So, this one here is the number of elements in A. We agree?
Yeah.
So this is A, this is B. I don't know why I just changed with the mark, but whatever, cool. A and B, we agree? Is A just the moon, or is A the whole circle? A is the whole circle. A only would be the moon. This is all of A, correct? So if I want to rewrite those, I would have 3, I would have 6, I would have, oh, why is it doing this? 3, I would have 6, I would have 9, I would have 12, I would have 18, I would have 15. So how many are in there? 1, 2, 3, 4, 5, 6. Right? Still counting the ones in A. Now, this represents what? And, or, what? Or. This is the union represents or. Now, or represents a snowman. And some people may say, a snowman, there's only 2 circles. How is that a snowman? Artistic abilities. Watch out. Don't be haters. Oh, come on, Blue. Some eyes. Got myself a, I'll give it some lines because it's a carrot. Got myself a little mouth ski. Some little buttons. Get some sticks. If we want to be very adventurous, give it a hat. And it's a little chilly out. That's a scarf. Scarf, you might say. So, everyone paying attention to me. This is silly. However, it is very important to not screw up, to remember it's a snowman. So what happens is people will tell me, oh, the snowman is A or B. Okay? They'll tell me, do not do this, because I'm going to erase it immediately. They'll tell me this and this. And they'll only give me the stuff here and the stuff here. Now imagine a snowman like that vertically. You have cut out its stomach. So you literally have the top part of the snowball, you have the bottom part of the snowball, and that's open. Is that going to remain a snowman, or is it going to crush down into a pile of snow? It's going to crush down. That is not a snowman. That is not a snowman. A snowman is the entirety of both circles. So when you do an or, you are literally going to do the whole snowman. That is both circles, everything included, correct? A lot of you will try and list at the very beginning of this unit everything but the inside of that snowman. That's not a snowman. That's going to be an entire ball. That's going to be just a pile of snow at the bottom. The thing is, gravity will take it and will destroy it if you cut that stomach out of it, right? So we would have the numbers 3, 6, 9, 12, 18, 15, 5, and 10. And we would have all of those because in or, did we not list them all? We listed them all when we did or. So the snowman is the whole thing. So we count them all. 1, 2, 3, 4, 5, 6, 7, 8. And I should be going A and B. Now, if it was a Venn diagram, you'd put all the numbers on it, correct? I'm only just stating the ones that exist now just to help you out. But the Venn diagram would have every single number listed. We just would only count the ones that mattered. So an example would be, you would have A, B, you have 3, 6, 9, 12, 18, 15, 5, 10, 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, 19. And I want the ones in B. Does it say B only or all of B? It's just B, right? B is a circle, a whole circle. So I would go like this. These are all the ones that are in B. So how many is that? 3. Life is golden when it's that. And then it gets to these ones where confusion, mass confusion lies. So I'm still going to write out all my numbers again. 3, 6, 9, 12, 18. Because my Venn diagram's not changing. Label my circles A, B. Nothing changed, right? The Venn diagram's the same every single time. This time, however, I want A and the complement of B. A and the complement of B. That's what this is. A and the complement of B. The better way to know what that actually is if you want to rewrite it in a different way, you could say A, instead of and, you could say A, but not B. A but not B. So where is A but not B located on there? Yeah. A but not B. I want A only, technically, right? It's just the A side. I want A. This is A, technically, right? But what is this as well? B. I want A, but not B. Correct? So I really only want A only. A, but not B. Right? So I want A only. Because I technically want where A and not B overlap, which is literally just A only. A but not B. How many is there? There. 5. This one I'm going to write them all out again. A, B, 3, 6, 12, 18, 15, 5, 10, 1, 2, 4, 7, 8, 11. It's not or, it's and. So you want what's the complement of B and A. The complement of B is everything but B. A is all of A. So you want the overlap between the two, which is just A only. If you take the complement of B as well, all of the complement of B, that's 4s.
Oh, okay.
We want the overlap between A and not B. And the so the overlap between A and not B is just A only.
Okay.
The other one, if you take all of those, it's the union. So you take all of the A, you take all of the not B, and you count it off. So remember when there's this little and symbol, this is what I always say. When I have A and not B, I always remember it's the crescent moon A. That's what this gives me. This always gives me the crescent moon. I don't even know how you spell crescent. We'll go with that. A. So when there's that and symbol, this A and the complement, you just do the crescent moon, so it's only the A. But it has to have an and symbol. Now this one wants not A, the complement of A. So that's everything but A, right? Everything but A. So if I used a highlighter, I want everything but A. So, okay, I go around A and I say not today. And then I highlight everything else. Right? I highlighted everything but A. Do you see that? Did I count them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Does that make sense? All right. We're going to skip these two for now, because I think I've overwhelmed you enough. We're going to go to the next one. If you don't have a highlighter, put your hand up. You can borrow one if it's there. If you don't have a highlighter. Highlighter? Anyone else need a highlighter? Everyone good? Equals? All right. So, this one says, in each of the following Venn diagrams, shade the region representing the given set. So, it says the intersection of the two sets. Intersection is this symbol. We agree? That symbol right there. So, that's this symbol. That's what intersection means. What does that symbol represent? What does that symbol represent in math? And or? And. And what shape is and? We talked about this. And is the eyeball. Correct? So you're going to shade in here. So if I ever ask you for the and, it's the eyeball in between. So your highlighter will do this substantially faster than my little tiny pen. I'm going to switch to a highlighter the next one. Okay, the next one is union. It's or. It's this one. What shape is or? Yeah, snowman is or. The whole snowman, correct? His stomach, everything inclusive. So or is the snowman. So anything that lands in the snowman, I would count. Okay. Then the complement of set A. The complement of set A. That's this symbol. What does that mean? Everything but A. So I circle A and I say not today. And I highlight everything but A. Right? So I circle around my A. And I highlight around it. So I would say everything but there, correct? So and is the eyeball, or is the snowman. Complement means everything but that. Give you a Venn diagram down here. I want you guys to list the elements in P. Does it say P only or P? P, so that's the whole P circle. That includes the overlap too, right? Everything in the P circle. P circle kind of sounds stupid, but anyways. Everything in the circle that is labeled P. Said better. All right. So that's the whole circle. All of P. Anything that's located in P gets written down. Do you agree? So I'm going to list 1, 2, 8, 9, 10, squiggly bracket. In that P circle, it doesn't say P only. It doesn't say P but not Q. It says P. So if it's in P, the P circle, the circle that is labeled P, I list it. Okay? I want you guys to try these. Make sure you're using pencil, because if you mess up, we can fix it. B, C, D, E, F. Try them out. So I want what's listed in Q. Does it say Q only? Does it say Q but not P? Or does it just say Q? Q. It's a single Q. I list everything in the single circle Q. Okay? So anything that's in the circle Q, I list. So I'm going to have 1, maybe, 1, 7, 10, and 29. Then I want what's in P and Q. And is what shape on the Venn diagram? The eyeball. So what was located in the eyeball? 1 and 10. That's it. Then we have or. What shape is or? The snowman. So anything that lands in the snowman, which is basically anything in the circles, I list. Correct? If you remember eyeball and snowman, your life is actually substantially easier. Okay? So it's the full snowman. So I'm going to go 1, 2, 7, 8, 9, 10, and 29. Any part of the snowman, the stomach or the top or the bottom, anything there gets listed. Yes? Okay, then I want what's not in P. Well, if I want what's not in P, I literally put my hand over P and then just list everything else. Right? So I go like this, not P. So that means I list 729, but I also list what? 11 and 16 too, right? So I just cover up P and I list everything else. A lot of people at the very beginning, because you're just learning, forget to list the outside. Not a big deal. You learn it, you do it. We're just learning. If you could do everything perfect, I'd be shocked, because I haven't taught you everything. I'm literally just kind of throwing you at the wolves here every so often. So if you get something, that's why I say use pencil. If you get it wrong, sometimes getting it wrong and then correcting it makes it stick in your head better. Like, oh, this is how I do it, rather than me just regurgitating all the information. You write it down and think you're geniuses because you're just copying what I wrote. Okay? You should make mistakes while you're learning. That's the point. If not, I don't know, so you shouldn't be in this class because you know everything. So, we're going to write 7, 11, 16, and 29. Not Q. We cover up Q. And we say 2, 8, 9, 11, and 16, right? All right. So we're going to look down here. We're going to actually look at these ones first. I know it seems weird, but these ones are easier to do. So not P or Q. If I actually drew that out, it would look like this. P or Q. P or Q is written like this in brackets, because it's in brackets, right? And then I would go like this, but not there. Now that sounds substantially hard. But if you just remember, what is P or Q? What shape is P or Q? The snowman. I want what's not in the snowman. That's it. So I want 11 and 16. Not to overthink it, right? If it's a snowman, we just want what's not in the snowman, which is 11 and 16. So this one, I want not P and Q. So P and Q is this shape, and then I want not. What is P and Q? What shape is P and Q on a two-circle Venn diagram? An eyeball. So I want what's not in the eyeball. You know, the proper mathematical terms of it. Not in the eyeball. On your diploma, please don't write, it's not in the eyeball. They're going to be like, who is this person and why are they talking about eyeballs? This is a Venn diagram. Okay, you'd say not in the intersection. But for us, we can do not in the eyeball, because we know the eyeball's in. So we would have everything but 1 and 10. So we're going to have 2, 7, 8, 9, 11, 16, 29. What if you list them out of order? Are you wrong? No, we don't care. Okay? Now, G and H seem super complicated. But I'm going to show you the little method that makes it super not complicated. Okay? So this one here had P or Q in brackets, so I put P or Q in brackets and put a not on it. We agree? Do you see how this is in brackets? I wrote that in brackets, put a not outside of it. This one is not P, so not P, and not Q, which to me is super confusing, personally. The and isn't as bad, the or is super confusing to people, me included. But what you can do is if they're both negated, do you see how they both have little complements on them? We can rewrite them with the complement outside. So if I get something with 2 complements, I'm like, no thank you, I'm not writing it like that. I see what you're telling me, I don't like it. So then I change it. I go, this is the same as going P, Q, putting the not outside. And what it does is it actually just changes the symbol in the middle. So instead of it's this A symbol, the and symbol, we're going to get a U. And what does that match? That exact question. They're the same. Because if I look for the places where it's not P and not in Q, that's just the outside, which happens to be this, not snowman, right? So if ever you have two letters negated, you can write the complement outside and then flip the symbol in the middle. So these are actually the same. This would be 11 and 16. And this one, not P or not Q, so not P or not Q, I'm like, no thank you, you're confusing. So then I just rewrite it with the P, the Q, the not outside, and that union symbol turns to a what? An intersection symbol, just the opposite way, right? And so now I want what's not in P and Q, which is the exact same question as this one, which is 2, 7, 8, 9, 11, 16, and 29. You have no homework for tonight, but you do still have those other two homeworks I gave you last week if you have not submitted them into Google Classroom, right? There's two sections where you put the assignments in. So as long as you've submitted them, you're up to date. If you haven't submitted them, submit them.